and congrats to being the 5th cohort. Today I will be talking about a domain that I'm quite familiar with. So I'm actually coming from the combined background of the two. I've been working in the field of AI for more than 5 years. In the beginning, it was focused on research, on computer vision, on trying to understand images from the algorithm's perspective. But a couple of years ago, I went into the generative AI field, as it was something very creative, very exciting, and for me, also having a background in photography, it was something that made me realize that perhaps AI could not just be a field I research, but it could also be a tool I can use to create. So that's a very short story of how I came into doing AI art and where I'm actually coming from. So in this course, I will start with some main points about AI. This is something, of course, we hear so much nowadays, and there can be some misconceptions or even some confusion with regards to what AI is. This term is used so interchangeably, so it's good to kind of dwell in to the basics and to actually talk about what AI is, what kinds of AI there are, and also how can you use AI as a creative tool for your own applications. As many of you here have such varied backgrounds and varied experiences, I believe that actually everyone will take home different parts of this lecture. So I just hope to give you some inspiration for some of the tools that you could incorporate into your own practices. So let's start with the elephant in the room and the question of what actually is artificial intelligence and what is it not. And the thing is that when we think about artificial intelligence, it sounds really scary. It sounds very sci-fi, dystopian. We attribute so many things to AI that it's not actually even capable of doing yet. And it of course makes us scared of what the future might bring. But the kind of true thing to realize is that AI nowadays is not as powerful and not as scary and confusing as it might seem. And even though some of the results and some of the technology that has advanced during the years seems so impressive and the capabilities are just beyond of what human minds can do very often, the thing is that AI, what we call nowadays, is the field of research that is using artificial neural networks. This would be the shortest definition. Artificial intelligence is not something that has consciousness, is not something that has sentience. Nowadays, I don't know how long this will last, but at least a couple years or decade or several decades, it's still a question for futurists on when will we have a very different kind of artificial intelligence. But nowadays, it's just the use of neural networks. So it's not as scary, and it's also maybe not as well, what's the good word? Not as magical as it might look like. And it has, of course, good and bad things. And the thing is that the AI that we have today is those neural networks learning from data. And there is no other signal that AI can learn from. It's not sitting silently in the box and thinking about the world, but it's just looking at the data and it's finding patterns in this data. So it's a very, very simple way to think about AI, but I think that it actually helps to understand its limitations and also to understand on how can we use that and how can we explore that and what can we do with that. And AI will only be as good as the training data in it. So this essentially means that the models that we see in articles and all those sensational headlines are usually the models that have been trained on such vast amounts of data And also they were trained on high quality data that it allowed AI to reach those capabilities that are possible today. Of course, when you dig a bit deeper, it's not just as simple as just having a lot of data. There's a lot of sophisticated parameters in those neural networks, a lot of mechanisms that researchers have been developing since the 50s. So a lot has happened, but the most important thing to realize is that data is the key element for any applications. And if you don't have good data, it doesn't really matter what architecture you have. It doesn't really matter what network you have. You will never really get good results. So AI does not get born from vacuum. It gets born from data. And as you realize that, another point might become obvious is that the field of AI is a bit different from the field of computer science before that, where, for example, when creating generative art or when creating different kinds of programs, we used to hard code rules. So for a few decades, when using computer science, we used to tell computers, do this and do that. And then if you see this value being higher than something, then do something else. And this is this set of rules to follow and this set of instructions that machine has to do is something that we see nowadays also in the field of more classical generative art approach. This is something where we would hard code those rules and we would instruct computer in a more clear way what to do. When we talk about deep learning, we usually have those networks that learn by optimization on the data, and it means that those networks don't have such explicit instructions on what to do. And they just look at the data and either they try to mimic that or they try to understand that. They maybe try to classify the data, to classify and differentiate between cats and dogs, or maybe learn to detect where the cars are on the picture. But it really means that we as humans don't tell AI things like, look for 4 wheels and metal structure and it should be moving on the road. This means that this is a car. We are usually just throwing a bunch of different images of cars from different angles, and AI just learns to navigate this vast space of data and to learn those rules on its own. So it's really very fascinating that those rules kind of emerge on its own. Now, one thing that is kind of important here as well as when we hear about AI in today's context, it's very often that we hear about DALL-E, ChatGPT, and many people actually think that this is the only AI that there exists, or that all AI is based on text. But the reality is that there is just many different ways of different architectures, of different AI types. And there is even no such thing as single AI, as I heard some people think. So it's quite important to make a distinction here as well for creative applications on what kind of AI types we can use. And the 2 main types would be GAN-based methods, so the methods that don't require text in a very, very simplified manner. And on the right-hand side, the clip-based methods. So those would be the methods that generate images by taking some text input. So this distinction is quite important due to the fact how those different types of AI learn and how they are trained. So all the models that you see on the left-hand side, they don't require text. They usually require collections of images. And methods on the right-hand side, they require both text and images to learn. And then at the inference time, when we are using those tools, we would input some text and get an image as a result. So the fundamental way of working of the tools like VQGAN, Midjourney, Stable Diffusion, and DALL-E are actually quite similar, as all of them are based on this model CLIP. So this model CLIP is actually also something that is very important in all of those applications, as it is the way of how they can learn to understand what's the relationship between images and text. So what is CLIP? CLIP is the model that learns to connect text and images. And this is initially the most important component of all those tools that use both text and images. And to be able to connect the text in a written form with the visual signal in the form of image, the CLIP has been trained on many pairs of images and text. So the AI model had quite a simple, if you can say so, task of connecting images to text. But of course, the task was not as simple because there can be different meanings of the same words, and also small changes in the images can mean, or in the text can mean very different meanings. So to be able to train such an intelligent model that would be able to connect two distinctive, very different worlds, more than 400,000 pairs of images and text were trained. And it was initially trained by OpenAI, and the idea behind CLIP actually comes from OpenAI and was introduced already a couple years ago. Now, this model allowed to train some generative models that were then able to create high-quality images. And as we have seen in the last couple of years, those images just have gotten better and better. And in 2018 or 19, the VQGAN and CLIP was one of the first models to make some waves in the popular discourse, as it allowed to create already some high-quality images. And users found that some of the text prompts improved the overall quality, such as Unreal Engine, for example, was very popular at the time. And the workings of VQGAN and CLIP are very similar to what we have in Midjourney or DALL-E. It is using text prompts to guide image modifications. And essentially, there is no training of the model, but the optimization happens directly on the input image. So what this thing means is that VQGAN and CLIP was the first in the family of models that used text to image, but this was already quite a big model that was very difficult to train yourself. It was not as huge as the current models, but it was something that already only a few were able to train on their own. And regular users, so for example, artists using text prompts, they were not training the model, they were just outputting the trained model, and this optimization actually happened on the outputs. Now going forward, OpenAI introduced DALL-E. Before DALL-E 2, the current version that is very popular, the previous one was a bit more limited, and it was also not released to the public, but it already had some great capabilities that were better than VQGAN, and their main advantage came from the fact that they were using a 12 billion parameter version of GPT-3 model, also a previous version of the current ChatGPT that you all are probably familiar with. So this model then went on to be improved with DALL-E 2. And one great change that happened in DALL-E 2, and also something that is another common factor among Midjourney, DALL-E, and Stable Diffusion, is the fact of using diffusion process. And this is a process that's actually coming from physics. Diffusion process has been researched for quite some time, but didn't have broad applications. And surprisingly, computer scientists have found that the diffusion is actually a very useful process to reconstruct images from noise to high quality. And even though only stable diffusion has diffusion in name, don't be fooled. Diffusion is used in DALL-E and Midjourney as well. So that's an interesting technique that is currently making all those details possible. It's also the process that is responsible for getting all the textures, all those nice little details that we see in the AI that is created today, as it just goes from blur and noise to something that is more and more detailed. In the DALL-E 2, as opposed to other methods, there is some restriction with regards to names and living people. And the model, while it's open to the public, the code was not actually open sourced. So we might just guess what's happening under the hood. But of course, most of the techniques used have been published as research papers, and those white papers are available for everyone to read. So this is why we know what's happening under the hood, even though we don't have direct insights into the code. Finally, well, not literally finally, but after DALL-E 2, model to make high waves was Midjourney. Midjourney, as I mentioned before, works on very similar concepts, but it's fully proprietary model, and it means that no code or no implementation details are released. There are also different versions of Midjourney coming all the time, and some of them have different aesthetic values. So this is something that I've heard many artists have experimented with, and some of them like particular versions of the model more. I have used the earlier versions of Midjourney. I haven't really followed the newest one, but I've seen some artists create some quite beautiful outputs. And well, similarly, I have this disclaimer below that there is no training of the model. Optimization happens directly on input image, which means that even if you feed an input image to such a model and you give a text query, only your image is changed, but the model is not trained on anyway. This is something that also a lot of people were asking me about all those models. What happens if we feed those text and we generate those images? Does it make AI smarter? Does it make AI learn from our inputs? And the short answer is no. There is no direct learning. The model is just used at the inference time to change our images. However, it should also be noted that companies such as DALL-E, Midjourney, and Stable Diffusion, they might be collecting the text prompts that we are using, and maybe they can use them in the next iterations of creating the further versions of the model. So the learning is not happening on its own, and we are playing with a trained model. And finally, the Stable Diffusion, the last addition to the powerful trio of text-to-image models. This one is different because it's fully open source, which is amazing for the community, especially given the fact that all those DALL-E Stable Diffusion models are very, very large. So, for example, this one was trained on 4,000 ultra clusters for over 1 month. So this is an insane amount of servers, of energy that has to be used to train one model like that. And only a couple entities in the entire world can do that. So it's not really democratic to have a monopoly on training such huge models. Which is an amazing fact that they made it completely open source and allowed the community to change the code, to work on different versions, to create something that would allow model fine-tuning. So really taking a trained model and tweaking it slightly. So something like light training, which is currently possible with the tools like Dreambooth. from Google. So it all was made possible due to the fact that the code was fully open source, and more people were able to use that. So this would summarize the text-to-image tools that are very simple to use, and the tools that allow such a broad range of people to try AI, to try AI art, as you don't really have to have any knowledge of AI. You just need to prompt into your browser. But these are not the only AI tools that you can use and the tools that you can play with. And the second big family of AI tools that has been for a while and longer than text-to-image tools are the family of AI models called generative adversarial networks. And GANs are the tools that are learning on data directly. So they are not trying to connect images with text, but they are trying to imitate whatever you show them. So it is popularly used with images, where artists or researchers would feed a collection of images in a particular theme, and then GANs would try to imitate that and create new images that would be somewhat similar but not really identical. So under the hood in GAN, there are actually two different models. One of them is called generator, or you can think about them as forger, artist. And the other one is called discriminator, of which you can think critic or policeman. And the learning happens in a sequential manner, where one model tries to create something and then gets feedback from the critic. And critic might give some very constructive feedback saying, well, I don't like this one, but I like this for 10%. Or maybe this element here is actually quite good, but I don't like the other part of the image. So the learning happens in a very interesting manner, sequentially happening, where the forger creates an image, then it gets some feedback, and then it gets better. Then as the forger gets better, the critic also gets better at distinguishing which of the images are real and which of them are fake. So the critic actually has an insight into two of those. And it's also evaluated based on its ability, whether it's able to distinguish real images from the fake images. So it's a very fascinating idea and concept that's behind GANs. And this manner allowed GANs to create, to get some amazing results even a while ago, and even with resources a lot smaller than the text-to-image models. And one of the most popular types of GAN are style GANs, and those have also evolved through the years. Currently, the newest method is called StyleGAN 3, but StyleGAN 2 ADA is also a GAN version that I really recommend any artists to use, as it really has some interesting capabilities of mimicking the training data. And the way how GANs use is that, well, typically if you're an artist or creator, you have those collections of images that you can use, and then try to teach AI, learn from your style directly and try to imitate some things from your style. However, what's interesting is that what happens, those images don't get really imitated fully, but the most obvious patterns get extracted, and also you get some new forms created, which are similar to the training data, but not really. So this is this very fascinating process that allows you to get some insights through the neural networks to really kind of collaborate on the creative process. And if you wanted to train GAN on your own data, you should probably start with the three main questions, which are what is the theme you'd like to explore? What's your goal? And to focus on the data collection as well. So as mentioned in the beginning, data collection is actually the key to this whole process. So you have to make sure you have some good data. And for second to add a model, which is the one that actually doesn't need that many images for the training set. You can start your first project with as little as 1,000 images. And if you already have a model, you can train a related one with even smaller amount of images, such as 100, and use this model for training it further. So what kind of data can you use for that? You can take some of the pre-trained models, for example, the ones trained on faces. So if you were training on your portraits of faces, what would be really easy to train GAN on is to start with a model that already knows faces, some random people that are already generated with this pre-trained model checkpoint, and then to fine-tune it on your own data, which would mean that such a GAN would learn pretty quickly, and it would also be very much fine-tuned to your style. So there are many pre-trained models available. Some of them are trained on paintings, on microscope cells, etc. But what is really cool is that by using those pre-trained models in a way where you use them as the first step in your process, you make GANs forget the initial training data and to learn your own, which means that there is very, very little data leakage from the initial of pre-trained models. And you're just fully responsible for your own data, and you're fully aware of what those models know and what they can learn. So, short example of what is good and what is bad training data when we as humans think of concepts. For example, such concept as Africa. If we go to Google image search, we can see that there are many different images related to Africa theme. Portraits, landscapes, maps, illustrations. And for us humans, they all relate to the same concept. But unfortunately, for GANs, they would not be looking very similar, as they learn on a very aesthetical similarity level. So you have to have images in your training data that share some aesthetically, some visual similarities in their features. So here is an example of the training data that I used in several of my previous projects. As you can see, this one is based on some organic growth, and also it had some solarization filter applied, which meant that the color palette was quite strong and something that GAN could learn easily, but also it was shared across the images in the training data. Another example of the training collection that has also worked very well with GANs are the images of neons taken at night. As you can see, there are several different viewpoints. Sometimes there are close-ups, sometimes there are images from far away. And this was something that GAN did not have trouble learning, as long as all of them contained images taken in the dark. Also bright colors, color palette, which was also repetitive across different images in the collection. So this is just to give you an understanding of what would be ideal for your training data to be. So really focus on colors, on patterns, on shapes. And what you usually create will be very different from what is in the training data. So it's a fascinating process to explore. Now going forward, actually, it's also not. It's also worth mentioning that even though apart from text to image, apart from generative images with GANs, there are also many other AI tools that you can use, and you're not really restricted to just using generative images. And you can also create text. Now, of course, we have ChatGPT, which is making the headlines. I have not seen yet any cases of art created with ChatGPT, apart from ChatGPT creating some generative art, I think, with the code it has written. But perhaps it could be an interesting avenue to explore of how can you use that for art creation. Before ChatGPT, there was Sudowrite, an amazing tool that the creators from Verseverse, for example, were using in their collaborations between artists and AI, where it was used to create poetry. So an amazing tool as well. So generative text is something somewhat a niche in AI art, but I don't think it should be a niche, as there are amazing applications to do. So you can use it in a wide variety of ways. For example, you can draw inspirations for the description. In one of my projects, for example, I used Sudowrite to create the description of my works that were then fed back into the works as a way of AI manifesting itself in the work. Another amazing application of AI that is not so popular, I don't know why, is generative sound. And there is surprisingly a lot to be done with generative sound. There are some applications where you can create sounds according to a set of your parameters. One tool that I really love is called Beethoven AI. It is a great tool for example, visual artists who don't have the capacity to create music or don't have the skills required. So you can, of course, always collaborate with sound designers and producers, but if you want to create a short snippet of sounds that would add to your story, this is an amazing tool to use, and it also allows you to tweak the parameters in a very intuitive way. So let's say you choose mood, you choose speed, and you also don't really need to understand what's happening under the hood. What's fascinating, I've also talked to people behind Beethoven, is that they're now working on a tool that would generate sound based off video, which is something that for me would be amazing, as I very often have animations and want the sound to react to visual, and they're actually working on something like that. So yeah, there is just many inspiring tools out there that you can play with. So currently there is also the other way around that you can work to create audio reactive visuals, and this would be to take an audio track, take a trained GAN as an input, and then use the audio signal to guide the visuals. And it can be done, for example, using Lucid Sonic Dreams library. So this tool is not fully codeless. It requires some basics of code, but it's just a few lines. And as a proof, this last summer I taught a workshop in Barcelona where I taught photographers to do that in just under 3 hours. So I think it's feasible to do. I don't know if the video will play here, but we can try to see an example how it works. I don't know if you can hear the sound. Okay, amazing. So yeah, so here's an example of how the GAN would be reacting, and yeah, the initial audio was just taken as an original, and then all the visuals were produced using this library. This was one of my earlier models trained on some synthetic objects found in our homes and just artificial lighting. And I think the final set of tools that I wanted to mention is the tools used for post-processing. So probably many of you are familiar with that already. And if not, they are very beneficial for publishing all of your projects, whether they are created with AI or any other tools. The super resolution tools actually have become better through the years, and they really allow to increase the image resolution to vast amount. So some of the tools, this one is an older one that actually started the gold rush in AI art. And this is also, I think, the tool that Claire Silver has been using for a long time. So it really inspires some creativity. There's Runway ML, which is a great software tool that doesn't require coding and has most of the current state-of-the-art AI models implemented. It also allows you to train your own GAN without coding. So this is something that I really recommend artists that don't have any coding skills so far. There's also Playform. This is more for different kind of filters and style transfer methods. There's also something fun called Deep Dream Generator that you can experiment with. And some of the recommendations and tips and tricks if you decide to train your own model. The one essential thing to learn is some command line basic knowledge. There are many libraries that look complicated, that require installing some Python libraries, for example. But usually that can be done with just 3 lines of code and with some basic comments from the command line. So just learning a few of those would be really beneficial to run your first models. Navigating GitHub. So GitHub is this repository where you have all the libraries, all the newest AI architectures, and they very often, as mentioned, can be run quite easily through a couple of lines of installation in your Google Colab notebook, for example. So yeah, if you were to ask about the coding language, so in AI, the one that is most used is Python. Fortunately, Python is probably the easiest language there exists, and it's made quite intuitive. So if you were curious about learning coding and you were also interested in AI, I would strongly recommend learning some basics in Python. And yeah, that would be a great start that you can dig in deeper. And the toolkits that you can use to train your own models, fortunately, you don't really need to invest in any hardware. You don't really need to buy those expensive GPUs. What you can use is, for example, Google Collaboratory, the one that I really recommend for folks just starting out with coding, just learning their first AI models, is to take a notebook written by somebody and to run the cells, see what happens inside, and then with time to understand what's happening in those lines of code, and then to play with them, to change the parameters and to tweak the models and to see what happens, to really play with those. So Google Collaboratory is very easy to use, as it's essentially a notebook in which somebody else has written all the spells, magic spells that make AI work. But for more advanced users, there are also tools that don't require your own GPU card, such as Amazon SageMaker, GCP, and really a lot of solutions based on cloud, which are amazing to train and only pay for what you use. And some of the community etiquette that I think has emerged through the recent years, and I think it might be also interesting to revisit, given the fact of the recent explosion of popularity in AI art. some of the things that were used to be done, and it's cool to do. It's not really essential. There is no written guidelines, but I think it's more as an etiquette. So first of all, to credit the model that was used. So if you're using raw outputs and you're using somebody else's open source model, it's really a nice gesture to mention that you used it. Also, credit the data set if not using your own. This is something that we see, especially right now. Problems emerge with models that were trained on data sets where the ownership was not there. So, for example, in Delhi, we can see those images emerge sometimes with the Getty logo, which just means that there were some copyrighted images used in the training data. And of course, it means it's problematic because, well, nobody gave the permission to train on them. So as an artist, it's good to be careful about those things and to always use data sets that are available to do that. For example, if you're using image platforms such as Pexels, they allow you all kinds of usages. They're copyright-free images, but other platforms, especially nowadays, they added some clause that explicitly state that you cannot use their images for AI training. Which is of course something you have to be real careful when collecting data. But there are also amazing data sets, for example, from the museums that are open source and are available to use. The only problem is that a lot of the open source people are now having second thoughts as they realize that this thing can be monetized. And yeah, there's of course a lot of discourse about copyrights right now. The first lawsuits, I think, emerged. So it will be interesting to see what happens next. But I think it was quite natural that training your model on copyrighted images and thinking that you would get away with that was not probably the right way to go. So it's not strange those lawsuits are appearing. So yes, be very careful about your training data. Don't take anyone else's images. Curate your outputs. Don't really spam. It's also true with text-to-image tools. The fact that you can generate 1 million images doesn't mean you should. And also curation is a craft in itself. And being able to navigate those vast outputs, I think, is something that currently emerges as even the greater skill than creation, as we don't really have to be perfect at the craft of Photoshop, photography. We need to be better at taste and curation and telling a story. This is something that I think might emerge as the next essential skill. And yes, also when you're training on other data, you have to be aware of the potential biases. So if you collect your own data, you're probably familiar with what's inside, but also be careful that it will be just augmented if there is any bias. It can not always be so serious. So for example, a funny fact that I had when I was training one of my first models is that I was taking photographs around Warsaw during the daytime. And I focused on the buildings, and I was just thinking about perspective, colors, all those things that photographers are thinking about. But then when I trained my first AI model, I realized that I didn't even notice that there are so many tram lines in the photographs. And what happened is that AI took those tram lines and just augmented them. It put it everywhere. And it just realizes all those small things that can be in your images. If it's imperfect cropping, if it's not best quality, AI will just learn to augment that. So this is one of those things that you have to be careful in your training data. And finally, also to be mindful when training your own models. It's essential to be mindful of the carbon footprint, not training unnecessary models. What is very cool is the thing that I very briefly mentioned is the possibility to fine-tune your models or reuse your models. So this is where you would take your previous model and then show it some new data. And this would mean that your model would require training for just an hour instead of half a day. So this is something that I really like using because it also means that after some time you just have this palette of different models that you can reuse and combine and play with them and mix and merge them. And it's also a very interesting creative application. Here also I have some additional learning materials for those interested. Especially for those interested in training GANs, I recommend the Style GAN course by Derek Schultz. It has a lot of amazing tools, but also explains how the Style GAN works. So it would be a great tool for those wanting to learn more. A great course from MIT about deep learning for art aesthetics and creativity, and some of the articles that I also have included here. As well as some useful tools. So if anyone is working with video and needs some upscaling, Topaz Labs is probably the best tool to use. Apart from the tools I mentioned earlier, there's also another enhancer and upscaler of the images. Some links that I have here. I will actually share the link to the presentation here so that you can use any of the links that were in the slides, and if some of the tools caught your attention to have that. I just posted that so you see it in the chat. I think that was the last slide. Yes. So yeah, I would be very happy to hear your thoughts and any questions you have, or maybe anything you were wondering about AI, or in this presentation, or in general, maybe something that I didn't touch upon, but you were curious to know how it works. Yeah, thank you so much.
Hi, Ivona. It's Connie.
Hi, Connie.
Hi, how are you? I've always appreciated the depth of knowledge and expression that you bring to your art and your work. So first, I have to just say, really, really appreciate what you've shared here, because there's so many gaps in my knowledge that you've filled, and I didn't even realize I had. But I'm especially curious about the AI-driven generative sound models. Do you happen to know where the data sets for tools like Jukebox and Beat Oven come from?
Yeah, that's a great question, and I'm really happy to hear that you're interested in this field in particular. So, the data for music has one advantage over the image, is that even a single music track already contains so much audio signal. It's like training on videos. Video is just thousands of images, and similar thing is true for audio. So essentially, those models don't need such vast data sets. And it would all depend on the applications. So Jukebox and Beethoven, they didn't really share their training data, I think, as their proprietary models. But there are some open source models available. They might be limited, but they also might depend on the application you might want to do. Because especially in music, if you want to train, you would focus on a particular style. So there is, for example, there is a very funny website, I think, that plays metal music for infinity, and it was trained on metal music. So those data sets would not use different kinds of music. And there are also models trained on classical music that work very well. So those models would also be focused, for example, on a particular artist. Like there is Beethoven, there is Mozart model or Bach model, and they were just trained on those artists' music. So the good thing is that those data sets don't have to be big. So if you have some sound library, you might probably be able to train it on your own. I unfortunately haven't trained any audio models, but I can dig around if you're interested in that, and would be happy to try and point you to some interesting resources.
Oh my God, that would be amazing. And actually, I'm just kind of curious about your perspective. Do you feel like just where these generative audio models are they closer to like more like GAN or diffusion processes?
So they are definitely closer to GAN because, well, they don't use any text and there is no duality in the data. So we are not trying to connect different kinds of signals. We just have audio signal and we are learning on that and we are extracting patterns from that and we are trying to generate that. And actually, there is a lot of similarities between audio processing and image processing. And even historically, a lot of the methods that were used for images were then applied to sound. So convolutional neural networks, one of the basic architectures in image processing, was actually then reapplied also to sound. So those would be similar to GAN, but like GAN in 4 dimensions because we have this time dimension as well.
Oh, that is fantastic. Thank you. Super helpful.
Yeah, thank you so much. And thank you for your amazing questions. Happy to see you here. I see we also have a question from this collective about what tools did I use for my FX hash projects. Thank you for this question, and also so happy actually to see so many familiar names here. It's such a nice crowd. But it really depends because I had free FX hash projects. And in the first one, I used generative text, as mentioned before, to embed the text back to the images. But this generative text was working on generative imagery, and that was actually outputs from cropped parts of my analog images. So it was GAN trained on analog photography. And then it had multiple outputs at lower resolution that had some quite abstract patterns and shapes. In meta-latent glitches, the approach was quite similar in a way that it was also pre-calculated GAN outputs that were then fed into the generative pipeline. So there are 2 parts of the model. The one that I kind of select the seeds that I will then use in the second part of the model. But as the size limitations on FX hash are just 30 megabytes, I could not directly embed the model inside. So it was something that I wanted to really do, to embed the model and to have something create high quality outputs in the browser. This is why in the third project, which was actually very reversed and a more conceptual project, in Whispers in Code, my third FX hash project, I decided to have AI in browser, but a very different kind of AI. It was also inspired by the fact that there was a boom in text-to-image generative AI, and everybody was thinking that AI is just text-to-image. So I decided to go against the flow and not use AI to generate any images, but to use AI as an instruction giver. So usually we just tell AI, do this and that, train, learn, do better. And I wanted AI to give the power to make those instructions, and as humans to be the procedural part in the creation process. So there I used ML5 library in JavaScript that I trained on cropped images with the instructions. So such a model would have an image as an input and an instruction as an output. And I trained it in the browser. So ML5 is actually a very cool library for those more familiar with JavaScript. It also has some pre-trained models for object classification. For example, you can classify different objects, and this mobile net architecture will tell you what is in the image. But you can also train your own models. Of course, they would be more limited as they just run in your browser. And depending on whether you have a GPU or not, they would run slower or quicker. But yeah, there's also a way to do that. And yeah, I think it covers all of that. So yeah, my point is that there are many different ways to use AI in your projects, not just limited to those we are most familiar with. Okay, I think this is all for the questions. So again, thank you everyone for showing up, for your wonderful comments, reactions, and if you have any additional questions that are not covered in this presentation, feel free to reach out to me. And on Twitter, I might have closed DMs, but on Instagram, they are still open, or just email me from my link tree. And yeah, it was amazing talking to you guys. Thank you.
Thank you so much, Ivona.
Thank you, Ivona. This was wonderful.
Yeah,
Ivona, it was absolutely a privilege to hear from you.
I admire your work from the beginning when I came into here, and this was really, really helpful. Thank you. I'm also very interested in the audio.
Amazing. Very happy to hear that.
Thank
yeah,
you,
I love your work.
Sorry, Marta. Go ahead.
No, it just I was captivated by Ivona's work right away because of the kind of urban quality of it, and just just how wonderful you work with AI. But this presentation was very helpful. It inspired me for some of the work that I'm doing. Anyway, thank you so much, Ivona.
Oh, thank you. That's a wonderful feedback. I'm very happy it has inspired a thought of you. That was my goal.